Yeah, there is. Okay, so last lesson we did gradients and then we did some equations of lines, but we were pretty much sticking to the y equals mx plus b for most of the questions that we did. Today we want to explore some of the other options as well. So we have our y equals mx plus b there at the top of the page. We can always use that one if we know the gradient and the y-intercept. But we also need to use this one a bit more today, the y minus y1 equals mx minus x1. If we have a gradient and a point, but the point is not our y-intercept, then we need to use that version of the formula. This next one, the 2-point form, is basically combining your gradient with the point gradient formula. If you have got 2 points, you can use these, and you can use them in either form. Personally, I usually prefer that one, but you can use either one. All it is, see this form here, y minus y1 equals m bracket x minus x1. There's your y minus y1 and there's your x minus x1. The m, we're just replacing the m with our gradient formula, which was y2 take y1 over x2 take x1. Okay, just putting that in. You don't have to do it in one formula like that. You are welcome to just go, oh, I've got 2 points. Let's use the gradient formula, find the gradient, and then put it into this formula. Okay, but this is an option to make it a little bit faster, and speed is always a good thing in advanced because often time on test is limited. Okay, so there's another note there. Concurrent means that the line passes through the same point. We did that before as well. So examples, number 1. Find the equation of a straight line that has a gradient of -5 and passing through the point -2, 5. Okay, so we have a gradient, we have a point. The point is not the y-intercept, so I need to use my point gradient formula. So this is going to be my m, the x1 and the y1. The point gradient formula is y minus y1 equals m, x minus x1. Okay, and I sub in. So there's always an x and a y that stays in the equation because I'm finding the equation of a line. So it's y minus 5 equals m is minus 5, x minus minus, which becomes a plus 2. So I expand the brackets. Oops. So it's minus 5x minus 10. And remember I said if the question doesn't specify, I'm happy for you to leave the question in either form, either gradient form or general form. This one, it's going to be very easy just to move that minus 5, move it across to have it in gradient form. So I'm going to do that. Y equals minus 5x. When I add the 5 over, it'll become a minus 5, so that's in gradient form. Okay. Question 2, find the equation of the straight line passing through, and I have 2 points. So we can use the 2-point formula. Are we brave enough to use the 2-point formula, or would you like to do it in chunks? 2-point formula. All right, here we go. So I'm going to use the version, because there was 2 choices there, the y minus y1 over x take x1 equals y2 take y1 over x2 take x1. Okay, that was the second option that we had there. I'm going to label my points. x1, y1, x2, y2. And it's just subbing in again. So y take away y1, 2 minuses make a plus 2. X take away 3 equals y2 is 5, minus minus makes plus again 2, and 8 take away 3. Okay, little tips to look out for. These numbers here and those numbers there are always going to be the same because it's y1, x1, y1, x1. See that? Got to keep the order the same in each one that you put in. All right, let's tidy up the fraction on the right-hand side. I have y plus 2 over x minus 3. 5 plus 2 is 7. 8 minus 3 is 5. Now, I'm trying to get an equation here. I have fractions on both sides, so I can cross multiply. Yeah? So I'm going to move over here so I have a bit more room. The 5 is going to multiply to the top up here, Is it okay if I expand out in the same step? Is everyone going to be okay with that? So that's going to be 5y plus 10 equals, then I times the other way. 7 times the x minus 3 will be 7x minus 21. Okay, now either general form or gradient form. This one definitely looks better to go to general form because I've got numbers in front of my x's and y's. So the x is already positive, 7x. It was positive where it was. So I'm going to move the 5y behind it, so it'll be minus 5y. And the 10 needs to move across, so I'll be subtracting 10, which makes negative 31 equals 0. Okay? Next one. Question 3, find in general form the equation of a line with an x-intercept of 4 and a y-intercept of 3. Now you could do that as 2 points. An x-intercept of 4 would be the point 4, 0, and the y-intercept of 3 would be 0, 3. However, remember I said speed is key. We want to save as much time as possible. Yesterday I gave you another formula that was what we called intercept form. Do you vaguely remember that? Yeah? It was, let me make sure I use the right letters. It was x over a plus y over b. X over a plus y over b is equal to 1. Okay, and the x and the a, and the b, the a is the x-intercept and the b is the y-intercept. So you can just put those straight into that equation. So that would be x over 4 plus y over 3 is equal to 1. Now, I've got the equation, but I need to have it in general form because the question specifically asked for general form this time, which means I want to get rid of all of those fractions. I could times everything through by 12, okay, because 3 and 4 in the denominator is 12. Timesing, I'm going to put them in here, I'm going to times that by 12, I'm going to times that by 12, and it also means I have to times that last number there by 12. 12 divided by 4 makes 3x, 12 divided by 3 makes 4y, and 1 times 12 is 12. That is almost general form. I just have to have the equal 0, so I just need to move the 12 across. So 3x plus 4y minus 12 equals 0. Okay, often in these questions there is multiple ways to get to the same answer. As I said, you could have used the 2-point formula again, and you would get there as well. I can see a few people still frantically writing that down. We're good? Almost?
Yeah.
Okay. Question 4, next page. Given the points A and B, find in general form the equation of the perpendicular bisector. Okay, perpendicular bisector. You don't need to draw a diagram, but what this means is that I've got a point A and B. This is nowhere near any kind of scale here. A and B, and I'm trying to find the equation of a line that is going to bisect that line AB, and it's going to be perpendicular. And I want to find the equation of that line, that second line that I've just drawn there. Okay, so first of all, the bisector part. Jess?
What does bisect?
Bisect means to cut that interval in half, which is why I put these little lines in here to show that I'm going to cut A and B, so those two bits there are the same. It means the midpoint. Okay, so let's find the midpoint of A and B. So that's the capital M formula, where we average the x's. So that's going to be 4 plus 0 over 2, comma, average the y's, 0 plus 10 over 2. Okay, the first one, 4 over 2 is 2, and 10 over 2 is 5. So the midpoint is 2, 5, okay? We've got that part. That's going to be the point that I'm going to be able to use to find the equation. But now I need a gradient, okay? And that's the perpendicular part that I've got to work on. First of all, I need to know the gradient that I've been given. Okay, I've got these points A and B. I need to know the gradient between those 2 points. So I'm going to call that little m of AB, because I'm finding the gradient of AB. So this is the y2 take y1 over x2 take x1 formula. So I'm subtracting the y's. That will be 10 take away 0 over 0 take away 4. So that's 10 over minus 4, or simplified, minus 5 over 2. Okay? That's the gradient of AB. I want to find the perpendicular gradient to that, which normally we call that our M2. Okay, and the formula is minus 1 over the first gradient, which in this case is my M of AB. Okay, so it's minus 1 over minus 5 over 2. But remember, all that means is turn that fraction upside down, which will make a 2 over 5, and the 2 minuses will become a plus. Okay? So you don't have to write this little bit of formula down. Some of you just like going, oh, negative reciprocal done. And that's fine. Okay, so we have our point. We have a perpendicular gradient. So now I can find the equation of this line using the point and the gradient. Point gradient formula. So that's the y minus y1 equals mx take x1. So that's y take away my y value, which is 5, equals m is 2 over 5, x take away 2. Okay? It says in general form. I was just checking my question, looking back there. It says find the equation in general form. So with that in mind, I'm going to times the 5 across to the other side so I can get rid of the fraction straight away. So that's going to be 5y take away 25. And the 2 that's on the top is going to expand through that second bracket, 2x minus 4. Now to get everything in the right order, the x term needs to be positive. It's positive where it is. So the 5y and the minus 25 I'm going to move to be on the right-hand side. So that's 2x minus 5y. And the minus 25, I'll be adding that to the other side, which means a positive 21, because it's minus 4 plus 25 is a positive 21. And there's my equation of my perpendicular bisector. Jess?
What's the equation called where it says MAB?
That's the gradient formula. That's your y2 take y1 over x2 take x1. That's one of our gradient formulas. Okay, one more question here, number 5. Show that the lines, and there is 3 of them there, are concurrent. What does the word concurrent mean? They go through the same, collinear was go through the same, have the same 3 points on the same line. Concurrent means they all go through the same point. Okay, so it's going to be 3 lines. Again, this is not to scale. Here's my Cartesian plane. But 3 lines going 1, 2, and the third one, all 3 of them are going through that same point. Okay, that's what concurrent means. So this is just simultaneous equations with an extra kick. I need to prove that all 3 of them go through the same point. So I take 2 of them. I usually just take the first 2. So I'm going to take the 2x minus y plus 1 equals 0. Although, how about I rearrange that, preempting what I'm going to do here. Let's get the y equals in that equation. So that would be y equals 2x plus 1. So that's the first equation, but I've just rearranged it to get the y by itself. That's going to be my equation 1. The second equation is x plus 3y minus 17 equals 0. That's equation number 2. And I've set myself up to do a substitution. So I'm going to sub 1 into 2. Okay, so where the y is, so this is my y, 2x plus 1. It's going to go in where that y is in the second equation. That gives me x plus 3. Instead of y, I get 2x plus 1 that I put in brackets. minus 17 equals 0. Okay, I'm going to solve that for x. So I expand the brackets. Okay, collect up the x terms. So 1 plus 6 is 7x. 3 minus 17 is minus 14. Move the 14 across and divide by 7. Okay, so I have x equals 2. Then I find my y value. I'm going to sub that into equation 1. Okay, that's the easier one. So y would be equal to 2 times 2 plus 1. So that's equal to 5. So I have a point 2, 5. I have shown that those first two lines both go through that point. Now I just have to make sure the third line also goes through that point. You don't have to do simultaneous equations again. Instead, all you have to do is sub in the x value into that third equation and show that you get the right y value. So I'm going to call this equation 3. And I'm going to sub x equals 2 into my equation 3. Okay, so equation 3 was 2x, that's 2 times 2, minus 5y plus 21 equals 0. And we solve for y. 2 times 2 is 4. Okay, I have minus 5y. 4 plus 21 makes 25. Just moving things across. Maybe I'm going to go over here. I'm running out of room. So that's 5y equals 25, which means y is equal to 5. I hope you guys are all good with the solving part. And I got the same y value, didn't I? Okay, the y value I knew I had to get was a 5, and I got a 5, which means that all three of those lines go through that same point, and I can just say, therefore, the lines are concurrent. That's it. Not too bad.